Hello, our names are Reed Snell and Mackenzie DeIuliiS. These are the in-process diagrams and gestural drawings of our work, Tensile.
This view is meant to demonstrate the potential robotic inhabitation of our proposed facility. Our thesis, a hope to challenge the pedagogy of robots as purely a means of making art or robots as purely tools of industry and task them with functioning as both, is explored through this architectural intervention.
The site is located at 120 East 5th Street in the historic East Village of Des Moines. It sits adjacent to a formerly dilapidated but historically significant train depot and an inactive rail line. As a part of our proposal, we are suggesting that the City of Des Moines follows through with their proposal to rehabilitate the rail line into a pedestrian and bike path. This addition to our site would increase the public's exposure to these new technologies.
At the onset of this semester, we were tasked with researching 3 significant contemporary design robots, including their production process and their spatial requirements. Through this research, we became familiar with Maria Yavlonina's MOFRES robot, a string-weaving multi-species robot. This diagrammatic exploration of her work was meant to be an analysis of body standards and their interactions with different robotic species.
In their current form, Maria's robots function through a system of vacuum, suction, or magnetic forces. They have been used primarily to date as means of artistic intervention. They often result in experiential displays. Maria has developed a family of robots, and our project will actually be best served by using the rail climbing robot. This does not go without saying that the operating surfaces that exist in our project could be adapted to facilitate any robot in the family.
Motivated by the aesthetic appeal of a model made at the beginning of our careers as architecture students, we began to consider the MOFRES robot as one of the main architectural aspects of our site, rather than a robot hosted by the facility. In our thesis, we had considered the implications of robots being used as more than purely art or purely production. From there, we made the move towards robots acting as a means of production and framing the process of production as art.
The required program for our facility includes robotics labs, an education suite, an administration suite, a research suite, and public spaces. In this diagram, you can see these spaces highlighted, as well as a breakdown of the square footage associated with each space in our building layout.
We believe the process of making occurring on the site would go as follows. 1. Determine the desired form to be constructed. 2. Determine how the form needs to be woven. 3. Determine if a new or existing robot is needed for the task. 4. Fabricate the necessary robot. 5. Allow the robot to complete the woven structure. 6. Create a rigid piece using the woven form. 7. Cure form. 8. Remove from mold. And 9. Send to the final location. Our primary inspiration for the existing building and site was to embody a process of gradation. From human through production, our building embodies this through the physical manifestation of height, a slow rise from the primary human inhabited portion into the robotic domain. The space we found ourselves struggling with most was the in-between. The gradation of height was our start, but we felt that it was most important that we melded the inhabitation of each space. While our facility caters heavily to research and the people composing it, most of the site is and will remain the domain of the robots. Beyond our thoughts toward the physical inhabitation of the site, we were guided heavily by the idea that our robotic facility should be focused primarily on the use of these technologies to further research into their potential as instruments of construction. In this facility, we hope to create an in-between place, one that's focused on the interaction, the gradation of human and robotic simultaneous inhabitation. Within the production site of the MOFRES robot, which moves through the process of weaving, the results of the weaving will result in large-scale resin cast columns that could be produced here, but could not be produced in another facility because the technology is not currently available.
Within this diagram, the proposed process of the production is in action. It also depicts the constant changing of the facade conditions that is intrinsic to this process. Each bay within the production facility is able to independently function, which would allow for multiple completely disparate stages of this process to be occurring simultaneously. Also necessary is the proposed system is an overhead multi-axis caddy robot that would act as an intermediary between the two-dimensionally functioning robots on the gridded structures. These robots would carry the cord back and forth between either side of the production field.
The importance of our plans in their current state is to show the location of the egress stairs and that the grid that has followed through the development of our site. These sections begin to show the assembly, but we plan to refine these documents and supplement with more details that will hopefully clarify the multiple systems that exist within our project.
Not currently shown in our renderings or diagrams is a plan to use fritted glass on the surfaces of the building that are not populated by the robotic processes. This system will function as a shading device in the sections of the building that are not shaded by the weaving. It will also conceal the slab edges. We will also have a large reveal in the fritted glass where the atrium exists.
Thank you for your time.